Hello everyone, this is our video on writing chemical equations. I want you to make sure before you watch this video that you're comfortable with writing formulas of ionic compounds. So if you haven't reviewed that already or watched the previous video, make sure that you watch that. Before we start, I want to talk just really briefly about some questions you guys asked. You guys asked good questions, so good job. About the reaction rates assignment that we did last time. A lot of people had a question about this question, which you may or may not have had on your homework, but we'll talk about it. Refrigerated foods stay fresh for long periods. The same food stored at room temperature quickly spoils. Why? So the answer to this, you see there's three options. It's just what the refrigerator does, there's less energy in the fridge, and putting food in the fridge prevents all collisions from happening. The right answer is the second one. There's less energy in the fridge. Food spoiling is due to chemical reactions. So you all know that reactions happen more slowly at colder temperatures. That is because the molecules are moving more slowly, so they're not colliding as much, and they're not colliding with as much energy. So in the fridge, there's just less collisions, and so you're gonna have the food not spoil as quickly. It is not possible for the fridge to prevent all collisions from happening. For that to happen, you technically probably have to be at like absolute zero, like a temperature that's so low that your molecules are not moving around at all, which is a temperature that does not exist in any fridge or really anywhere in the universe. A couple of other good questions I wrote down. Are enzymes and catalysts the same? Yeah, enzymes are a type of catalyst, so they're the same thing. What are some common catalysts? So obviously enzymes that are in your body, those are very common. Also, your car has something called a catalytic converter. The catalyst in your catalytic converter is some kind of precious metal, usually like platinum or palladium or maybe rhodium. And then someone asked, are there reverse catalysts? So like something that makes a reaction go slower. And the answer is yes, they're called inhibitors. They're molecules that usually bind to catalysts and stop them from acting. So that's kind of a biochem thing if you're interested in that. All right, so those are good questions. Let's move on to writing chemical equations. Oops, let me cover that up. So to start with, we need to know just a little bit of vocabulary about reactions. So I'm going to, and you guys should too, should be on page 89. We're going to write out a reaction, and it's going to be the reaction of natural gas, which is methane, with oxygen to make carbon dioxide and water. So this is burning natural gas. Burning natural gas produces these things. So in any chemical reaction, the things on the left are called the reactants. You may know this already, but we just want to make sure everyone's on the same page. So the reactants and the things on the right are called the products. You can remember that because the products are produced. So that should make sense. The arrow, you can think of that as meaning produces or yields, which basically means makes. And then the plus sign can be a little bit confusing to some people. This does not mean that these two things are combining into one molecule or anything like that. You basically can just think of it as the word and. So you would read this reaction as methane and oxygen react to produce carbon dioxide and water. Okay, a couple of other things that you might see in reactions that I want to just point out to you so you know what they are. Occasionally, you'll see little letters in parentheses to the right of the parts of the reaction, like this. Those are states of matter. So this one is weird, but like obviously S is going to be solid, L is going to be liquid, G is going to be gas, and then we have this weird thing that's AQ. That's not really a state of matter. It means aqueous, and it means that whatever it's written after is dissolved in water. That's all it means. So what's going on here is that we have silver ion and chloride ion. They're dissolved in water, and then they combine to form solid silver chloride. All right, so our goal with this section is to be able to translate words into chemical symbols in reactions. So one last thing that we need to review before we do that are diatomic elements. So this was from section 7.1. So hopefully you remember a little bit about this. There's 7 elements that when they're alone, when they're by themselves in nature, they always come in pairs. And we talked about a good way to remember them was this Brinkelhoff mnemonic. So that means that bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, if they're by themselves, they come in pairs, always. So when we're writing chemical equations, if you see those, if you see like iodine reacts with nitrogen, it would have to be I2 plus N2. So that's important to remember. Okay, we're just going to do 2 examples of writing chemical equations. They're right here. I would recommend pausing the video and writing these down. In class, I would have handed out like a paper with these on for you. But since I can't do that, I would just write them down so you can have them in your notes to practice with and to review with. So go ahead and pause, write them down. Okay, hopefully you paused and wrote them down. So what we have to do here is we have to translate this into symbols. So it may seem intimidating, but you actually can just break it down into parts. So it says a solution of cobalt 2 chloride, so that's a chemical, is added to a solution of sodium phosphate, that's a chemical, to produce, that's an arrow, solid cobalt 2 phosphate, that's a chemical, and a solution of sodium chloride, that's a chemical. So there's going to be 4 chemicals, 4 compounds, and our arrow. Since these are written together right next to each other, they are 1 compound. This is 1 compound. Hopefully that's clear to you. So what we need to do now is basically write the formula for 4 ionic compounds. So if you know how to write formulas, this is not very hard. Let's start with cobalt 2 chloride. So that Roman numeral 2 means that cobalt is a 2+. Its symbol is CO. And then if you look on your periodic table and find chlorine, right there, it's a -1. So it's going to look like that. So that's +2, that's -1. Charges need to balance, so I need 2 Cl's. So I have +2 and -2. So the first part of my equation is going to be CoCl2. So it says a solution. That really means that the cobalt chloride is aqueous. So you could write a little AQ there if you want to. Canvas will not like it if you try to write the phase. So don't do that on Canvas. Just write CoCl2. Canvas won't even let you do subscripts. So you'll write this in Canvas just as CoCl, like big 2. Okay, so we did cobalt chloride is added to, so there's another chemical, a solution of sodium phosphate. So again, we have to look at our periodic table. Sodium is right here. It's a 1+. So Na+. And then phosphate is a polyatomic ion. And I can tell it's a polyatomic ion because it ends in 8. So you should have a chart in your notes that has a list of polyatomic ions. Or if you don't have that, you can just Google polyatomic ions. And there are lots of lists on the internet of different polyatomic ions that you can find. Here is a list that has some of them. I don't know if you can see this, but you can see phosphate is PO4 3-. So we're going to have PO4 3-. This is a +1, this is a -3. So that means we're going to need 3 Na. So this is going to be Na3PO4. That balances our charge. Okay. And then it says to produce. So that's my arrow. Now we have to do solid cobalt 2 phosphate. So we know cobalt is a 2+. Phosphate is a 3- because we already used both of these. This is one of those weird ones where since it's 2 and 3, you need 3 cobalts and 2 phosphates. So they both end up being 6. And then you'll write it CO3PO4 2. like that. That's a trickier one. And then sodium chloride is really easy. Sodium is a 1 plus, chloride is a 1 minus. So they're balanced already. So it's NaCl. And that's it. And on Canvas, you'll just be doing the same thing. You'll just be entering it, typing. You do need to use parentheses on Canvas. Okay, let's do this last example. Magnesium reacts, I guess I'll just cover all these words, that's kind of distracting. Magnesium reacts with hydrochloric acid to produce hydrogen gas and magnesium chloride. So let's find all my separate chemicals. I've got magnesium. It's reacting with hydrochloric acid, which is HCl, to produce, there's my arrow, hydrogen gas and magnesium chloride. So I've got 4 chemicals again. First one is just magnesium. So I go up and I check if magnesium is diatomic. It's not. So I just write Mg. Hydrochloric acid, they told me, is HCl, so that's nice. I don't even have to think about that. Hydrogen gas, so if I go up and look, hydrogen gas is H2, so I have to put H2 right here. And magnesium chloride. So since there's 2 elements there, that's going to be an ionic compound. So I'm going to need to do Mg 2 plus Cl 1 minus. So I'm going to need 2 chlorides. You could look these up on the periodic table. Sorry I didn't show you that. Magnesium is a 2 plus. Chloride is a 1 minus. So it'll be MgCl2. Alright, so that's how you do this section. If you were pretty comfortable with writing formulas, this section should seem pretty doable to you. So hopefully you guys all felt pretty good about that section. Let me know if you have any questions. I'm happy to answer emails or have virtual office hours with you guys. So hopefully it goes well. Have a good day.